our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for the class 12th, and that is your class 21. We had already completed your 20th classes lastly, and here we had completed your unit 1. We have completed unit 2, unit 3, unit 4, unit 5 and unit 6. Unit 7 we had started with, and that hopefully if it is not exceeded more than hours, we will complete that in this class only. That is your unit 7, the P block elements that we have to cover up here. On the same basis, lastly we had your sulfur dioxide, उसमें हमने preparation discuss कर लिया था. So for today we will have to discuss about the properties here for the sulfur dioxide. For that we have to discuss this here, which is the properties. In terms of properties, if I am going ahead, that we have to discuss here. And before starting with this, it's a huge request from my side to all the viewers to please go through with the subscribe button and please like, share and subscribe to our channel so that many maximum people can get the information at once, and even though you can also enjoy the video as well. On the same cases, we have to discuss here moreover related to this, the properties we have to discuss here, where the sulfur dioxide is a colorless gas with a pungent smell and highly soluble in water. It liquefies at room temperature under a pressure of 2 atmospheres and boils at 263 Kelvin. Sulfur dioxide, when passed through that water, forms a solution of sulfuric acid here, that we have to talk about it, which is your SO2 gases plus H2O liquid will give H2SO3 in the form of aqueous here. That is, it reacts readily with the sodium hydroxide solution, forming the sodium sulfide, and which then reacts with more sulfur dioxide to form the sodium hydrogen sulfide as well. And for the same case, we have an equation which is 2NaOH plus SO2. It will give Na2SO3 plus H2O here. On the same cases, for the same we'll talk about it, which is Na2SO3 plus H2O plus SO2 will give here 2NaHSO3 that we have. On the same behalf of it, that we have to discuss here, that in its reaction with water and alkalis, the behavior of the sulfur dioxide is very similar to that of the carbon dioxide, where sulfur dioxide reacts with chlorine in the presence of charcoal, which acts as a catalyst, and to give the sulfuryl chloride SO2Cl2, it is oxidized to the sulfur trioxide by oxygen in the presence of vanadium oxide catalyst as well. On the same cases, we'll go ahead for that, and that we have to talk about it, which is SO2 gas plus Cl2 gas will give SO2Cl2 get liquid here. For the same, we have 2SO2 gas plus O2 gas will give, in the presence of V2O5, that is 2SO3 gas here. When moist sulfur dioxide behaves as a reducing agent, for example, it converts iron third ions to the iron second ions and decolorless, that is decolorizes acidified potassium permanganate 7 solution. The latter reaction is convenient test for the gas as well. On the same cases, we have here the reaction that we have as follows is your 2Fe3 plus SO2 plus 2H2O, that will give 2Fe2 plus SO4 2 minus plus 4H plus as well. On the same cases, we have here that is 5SO2 plus 2MnO4 plus 2H2O. It will give 5SO4 2 minus plus 4H plus 2Mn2 plus here as well. On the same case, the molecules of SO2 is angular, and it is a resonance hybrid of the two canonical forms here, and that the structure for this we have to be as follows. That will represent here for the sulfur dioxide, and that we have is to be in the form of S double bond O, that is we have a 2 lone pair with single lone pair here, and then we have your, this is also having a 3 lone pair. On the same case it will give S, that is your the oxygen, there is your, we have, this is being having a 3 lone pair. This is for that. Now we'll talk about the uses here in terms of it, uses of sulfur dioxide, where the sulfur dioxide is used, that is in refining petroleum and sugar, and in bleaching wool and silk, and an anti-color, that disinfectant and preservative, and sulfuric acid, sodium hydrogen sulfide and calcium hydrogen sulfide, were industrial chemicals that are manufactured from sulfur dioxide. Liquid SO2 is used as a solvent to dissolve a number of organic and inorganic chemicals as well. Where there are many questions that we have to talk about it, which is that what happens when sulfur dioxide is passed through an aqueous solutions of Fe3 salt, and the other question is comment on the nature of the two SO bonds that formed in SO2 molecules, and are the two SO bonds in this molecule equal. And the other question is how is the presence of SO2 detected as well. Now we'll discuss about Oxo Assets of Sulphur here, that we have to talk about it. On the same cases we have to go ahead, that is Oxo Assets of Sulphur here. Oxo Assets of Sulphur. In terms of oxo acids of sulfur here, where the sulfur forms a number of oxo acids such as H2SO3 and H2S2O3, H2S2O6 here, O4, H2S2O5, H2S2O6 as well. And on the same cases here, for that X could be equals to 2 to O5, and that is H2SO4, H2S2O7, H2SO5, H2S2O8. And some of these acids are unstable and cannot be isolated, and they are known in an aqueous solution or in the form of their salts. Structures of the some important oxo acids that we'll discuss here in the detail about it. The first we have is your sulfurous acid. So sulfurous acid is also known as H2SO3. We have S with a single bond with OH, and this is double bond with O, and we have a lone pair as well. This is for sulfurous acid, which is H2SO3. Another we have is your sulfuric acid, which is H2SO4, that S double bond with O, double bond with O, then OH, OH. This is your sulfuric acid, which is H2SO4. Another we have is your Paraxo disulfuric acid, which is H2S2SO8, which is also known as Marshall acid as well. So that we have to talk about it. So on the same cases we go ahead here, that is we have as follows, which is O double bond S double bond O, and then we have your O, and this is your OH. With O, this is being connected to O as well. Then we have S double bond O, which is also being O, and this is being OH. So this is your Paraxo disulfuric acid. Write the name here. Paraxo disulfuric acid, and the formula for this we have H2S2O8. H2S2O8, which is Marshall acid as well, that has been known as. Now we have another one. So we'll go ahead with another one that we have here is your Pyro Sulfuric Acid, which is oleum as well. It is O double bond S, double bond O, then bond with O, bond with S, double bond O, double bond O, bond with OH. This is OH here. Let's go ahead, and that is the name of this we have, that is to be in the form which we have is your Pyro Sulfuric Acid, Pyro Sulfuric Acid, and that is known as oleum, and that the name we have here that has been represented H2S2O7 here. On the same cases, these were the structures of some important oxo acids of sulfur. Now we'll discuss about sulfuric acid, that is also an important one here. On the same cases for sulfuric acid that we have to talk about it. In terms of sulfuric acid, we'll talk about first, that is about your manufacture. In terms of manufacture, if I am going ahead here, that the sulfuric acid is one of the most important industrial chemical worldwide, where sulfuric acid is manufactured by the contact process, and which involves three steps. The first is that the burning of sulfur or sulfide ores in air to generate SO2. The second, that the conversion of SO2 to SO3 by a reaction with oxygen in the presence of the catalyst, which is V2O5. The third is that the absorption of SO3 in H2SO4 to give oleum, which is H2S2O7 here. We have a flow diagram for the manufacturers of sulfuric acid that will represent it, and that the SO2 produced is purified by removing a dust and other impurities such as arsenic compound. With the key steps in the manufacture of H2SO4 is the catalytic oxidations of SO2 with O2 to give SO3 in the presence of V2O5, which is your catalyst here. On the same cases, we have that reaction as well that we have to talk about it, and that is we have is your 2SO2 gases plus O2 gas in the presence of V2O5 will give you 2SO3 gas, where delta R is minus 196.6 kJ mole inverse, where the reaction is exothermic, reversible, and the forward reaction that leads to the decrease in volume. Therefore, low temperatures and high pressures are favorable conditions for maximum yield, but the temperature that should not be very low, otherwise the rate of reaction will become slow. And in practice, that the plant is operated at a pressure of 2 bar and the temperature of 720 Kelvin, where the SO3 gas that from the catalytic converter is here, that is in the form that we have in the same cases that we have to talk about it. We will discuss about the flow diagram for the manufacturers of sulfuric acid as well. That has been absorbed in the concentrated H2SO4 to produce the oleum, and the dilutions of oleum with water give H2SO4 to the desired concentration. And in the industry, the two steps are carried out simultaneously to make the process of continuous one, and also to reduce the cost as well. So with the same cases we will be having here, and that we have to talk about it, which is SO3 plus H2SO4 will give H2S2O7, that is your oleum. The sulfuric acid obtained by a contact force is 98% pure here, that we have to talk about here. Now we'll discuss about the properties of that, and we have that is your flow diagram for the manufacture of sulfuric acid as well. We'll discuss that in the later. First we'll complete that and then we have to discuss about it, and we'll discuss about properties as well. In terms of properties, where sulfuric acid is colorless, dense and oily liquid with a specific grade of 1.84 at 298 Kelvin, and the acid freezes at 283 Kelvin and boils at 611 Kelvin, where they dissolve in the water with the evolution of a large quantity of heat, and hence that dissolves in water with evolutions of large quantity of heat, and hence that care must be taken while preparing the sulfuric acid solution from concentrated sulfuric acid, where the concentrated acids that must be added slowly into the water with a constant stirring. The chemical reaction of sulfuric acid are as the given results of the following characteristics. The first is the low volatility, strong acidic character, strong affinity for water, ability to act as an oxidizing agent, and in an aqueous solution the sulfuric acid ionizes in two steps. That is the steps we have: H2SO4 aqueous plus H2O liquid will give H3O aqueous plus HSO4 minus aqueous. So which is that is of Ka very large here. The another we talk about it, HSO4 minus aqueous plus H2O liquid, that will give H3O plus aqueous plus SO4 2 minus, which is in aqueous as well. That is K of Az was 1.2 into 10 to the power minus 2. With a larger value of the Ka, where the K is greater than 10, that means that H2SO4 is largely dissociated into H plus and HSO4 minus. They get the value of the dissociation constant Ka, that is stronger in the acid as well. The acid forms two series of the salts, normal sulfates such as sodium sulfate and copper sulfate, and acid sulfate, that is your sodium hydrogen sulfate. Sulfuric acid becomes of its low volatility, and that can be used by the manufacture more volatile acids from the corresponding salts as well, and that they are forming here. On the same cases we have to go ahead and that we have to talk about it, and on the same basis that we'll discuss about the reactions as well, which is the reaction we have here is that is 2mx plus H2SO4 will give 2HX, that is plus M2SO4, where X can be fluorine, chlorine and nitrogen oxide, that is M is your metals here. Where concentrated sulfuric acid is a strong dehydrating agent, many wet gases that can be dried by passing through the sulfuric acid, that is provided the gases do not react with the acid, and sulfuric acid removes water from organic compound, and it is evident by its charring actions on carbohydrates, which we have as like C12H22O11 in the presence of H2SO4 will give 12 carbon plus 11 H2O. So here the hot concentrated sulfuric acid is moderately strong oxidizing agent. In this respect it is an intermediate between the phosphoric and nitric acid. Both metals and non-metals are oxidized by concentrated sulfuric acid, which is reduced to SO2, and for the same we have a reaction for this. Cu plus 2H2SO4 which is concentrated will give CuSO4 plus SO2 plus 2H2O. Another we have 3S plus 2H2SO4 concentrated, 3SO2 plus 2H2O, C plus 2H2SO4 concentrated will give CO2 plus 2SO2 plus 2H2O here. So for the same we'll talk about the uses here. In terms of uses, where sulfuric acid is very important industrial chemical, where a nation's industrial that is a strength that can be judged by the quantity of sulfuric acid and it produces and consumes, where it is needed for the manufactures of hundreds of other compounds, and also in many industrial processes the bulk of sulfuric acid produced is used in manufacture of fertilizers. Example, ammonium sulfate, that is superphosphate. Other uses of that are in like petroleum refining, manufacturers of pigments, paints and dyes, stuffs and intermediates. Detergent industry, metallurgical application. Example, cleansing a metal before enameling and electroplating, and galvanizing storage batteries in the manufacturers of nitrocellulose products and as a laboratory reagent as well. So the next we have that is your on site, that we have to talk about the another question that we have to go ahead, and that is also an important one here. On the same cases, the question we have, what happens when, that is being the question, and that will go ahead further here, and which is to be as follows. This is your the 13th question of the sessions as well. What happens when, first part is concentrated H2SO4 is added to calcium fluoride. So for that it forms a hydrogen fluoride, and it will be was like CaF2 plus H2SO4, it will give CaSO4 plus 2HF. The second is SO3 is passed through water. SO3 is passed through water, and the solution for this, it dissolves SO3 to give H2SO4, so that is SO3 plus H2, it will give H2SO4. The another questions in text question we'll talk about it, that is mention 3 areas in which H2SO4 plays an important role, and as I told you many times here, write the conditions to maximize the yield of H2SO4 by contact process. Another we have is why Ka2 is less than A1, and for H2SO4 in water here, that we have to talk about it here in the detail as well. Now we'll go ahead to discuss about the another group that we have to discuss here, which is your group 17 elements as well, and on the same behalf of it we will start discussing about it. That is group 17 elements. In terms of group 17 elements here, we are that the fluorine, chlorine, bromine, iodine and astatine, and that are members of group 17, and these are collectively known as halogens, where Greek halo means salt and gens means bond. So salt producers, we can say that the halogens are highly reactive and non-metallic elements like group 1 and 2. The elements of group 17 shows a greater similarity amongst themselves, and that most similarity is not found in the elements of other group of the periodic table, and also there is a regular gradations in their physical and chemical properties, where astatine is the radioactive element as well. Now we'll go ahead with further, which we'll talk about this is your occurrence. In terms of occurrence, that fluorine and chlorine are fairly abundant, while bromine and iodine less so, and fluorine is present mainly as insoluble fluoride, and that is your fluorospars, that is CaF2, and cryolite, which is Na3AlF6, and a fluoroapatite, which is 3Ca3 pure 4 whole twice dot CaF2, and of course the small quantities are present in soil, where river water, plants and bones, and that is teeth of animals. Seawater contains the chlorides, bromides and iodides of sodium, potassium, magnesium and calcium, but is mainly sodium chloride solution, which is 2.5% by mass, and that is the deposits of the dried up seas and contain these compounds. Example like sodium chloride, and that is your carnallite, KCl.MgCl2.H6H2O, where certain forms of marine life contains iodine in their systems. Various seaweeds, for example, like containing up to 0.5% of iodine, and child saltpeter contains up to 0.2% of sodium iodate. The important atomic and physical properties of group 17 elements, along with their electronic configuration, that we'll discuss here in the detail about it, and that even though we have to discuss here, which is in terms of, we will discuss about atomic and physical properties of halogens here. On the same behalf of it, we have to discuss here, which is the properties for fluorine, chlorine, bromine, iodine, and of course for the AD as well, and that we'll discuss about F2Cl2, Br2 and I2, and that for the same we have to discuss here as well. So before starting with this, we will have to discuss here in the detail about the electronic configuration, atomic and ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity as well, with the same for the physical property and the chemical property as well. So here we'll go ahead discussing about here in the detail about it. So here we discuss about the second property we will have to discuss about it, that is your electronic configuration. In group 17 elements, it's first is your occurrence here, where that the trends of some of the atomic, physical and chemical properties that we'll discuss here in the later. That is for the electronic configuration, where all these these elements have 7 electron in their outermost shell, which is Ns2 and p5, which is 1 electron short of the next noble gases as well. Talking about the third one, which we have is your atomic and ionic radii. In this, the halogens have the smallest atomic radii in their respective periods due to the maximum effective nuclear charge, and the atomic radii of fluorine, the other element of the second period, is extremely small, where atomic and ionic radii increases from fluorine to iodine due to the increasing number of quantum shells as well. We'll talk about the fourth one, which is your ionization enthalpy. In terms of ionization enthalpy, we talk about it, that we have to discuss here, and that they have a little tendency to lose the electron, thus they have a very high ionization enthalpy due to the increase in atomic size, and ionization enthalpy decreases down the group as well. We'll talk about the fifth one, which we have is your electron gain enthalpy. In terms of electron gain enthalpy here, that halogens have maximum negative electron gain enthalpy in the corresponding period, where this is due to the fact that the atoms of these elements have only 1 electron less than stable noble gas configuration, where electron gain enthalpy of the elements of the group becomes less negative down the group, and however the negative electron gain enthalpy of fluorine is less than that of the fluorine, and it is due to the smaller size of fluorine atom, and as a result there are strong electronic repulsions in the relatively small 2p orbitals of fluorine, and thus the incoming electron does not experience much attraction as well. We'll talk about the sixth category we have to talk about it, which is about electronegativity. In terms of electronegativity here, they have very high electronegativity, that the electronegativity decreases down the group. Fluorine is the most electronegative element in the period here. Now we'll discuss about the another one which we have to discuss here, and that is the another question we have to discuss here. On the same cases we'll have to discuss the physical property as well. So we'll discuss the physical property first, that is the seventh category, physical property. In terms of physical property, that halogens display smooth variation in their physical property, where fluorine and chlorine are the gases, bromine is a liquid, and iodine is a solid. Their melting and boiling point steadily increases with atomic number, and all halogens are colored. So this is due to the absorptions of radiation in visible region, which results in excitations of outer electron to the higher energy level. By absorbing different quanta of air radiation, they display the different colors. For example, F2 has yellow, Cl2 and that is greenish color yellow, Br2 that is your red, and I2 that is violet color. Fluorine and chlorine react with water, and bromine and iodine are only sparingly soluble in water but are soluble in various organic solvents such as chloroform, carbon tetrachloride, carbon disulfide, and hydrocarbons to get the colored solution here. One curious anomaly that we notice from this we'll discuss here in the tables, that is a smaller enthalpy of dissociations of F2 that compared to that of Cl2 here, that reacts with X or X bond dissociation enthalpy from the chlorine onward, that shows the expected, that is shows the expected trend, which is Cl that is greater than, as I told you what here, C bond Cl is greater than Br bond Br is greater than I bond I, where a reason for this anomaly in the related large electron repulsion among the ions that we have. So we are on the same cases, we have a numerical as well, and that we have to discuss about the chemical properties as well. On the same cases we'll discuss about atomic and physical properties of halogen first, that is your atomic and physical properties of halogens that we have to discuss here, and that has been the first. We'll discuss about property, then of course for the property we have here is, first we'll discuss about fluorine, chlorine, then bromine, iodine, and then we have your atomic here, and the properties we have to discuss as well. The first property is your atomic number. The second property we talk about it is about atomic mass per gram mole inverse. The third we talk about is your electronic configuration. And the next is your covalent radius. That is your PM. Ionic radius. Which is X per PM. Then ionization enthalpy, which is per kg mole inverse. Then electron gain enthalpy per kg mole inverse, and of course for that we have your electronegativity, and then we'll have to discuss about the delta of H of X minus per kg mole inverse here, that we have to discuss here. On the same behalf of it, and that is in the same references towards it, you can say that further we have to discuss here And on the same basis, we have to go ahead here as to be follows. So with the same regarded, we'll have to discuss many more things in terms of it, which is in the terms of properties as well. That is a different property. But first we'll discuss about it in terms of here only, and that is for the atomic number we have is that the fluorine we have atomic number 9, and for the chlorine that is just 17. We even have the bromine is 35, iodine is 53, and 80 that is we have is 85 here. For the atomic mass, we talk about it. For the atomic mass, we have as your 19.00, 35.45, 79.90, 126.90, and 210. The another we talk about it, which is for electronic configuration here, which is we have helium 2s2 2p5, neon 3s2 3p5, argon we have 3d10 4s2 4p5, then krypton, that is krypton 4d10 5s2 5p, that is your 5. Then for the another one it's xenon, that we have here is your 4f, that is xenon 4f 10 5, sorry 4f 14 of 5d10 6x2 6p5. Now for the covalent radius we talk about it, that is we have 64 99 114 133 dash. For the ionic radius it is your 133 184, then we have your that is 196 220, and then dash, that is not. For the ionization enthalpy we talk about it, that is 1680 and 1256, then 1142 and 1008 dash. The another we have is for the electron gain enthalpy is minus 333, minus 349, minus 325, minus 296, and dash. In the same cases for the electronegativity we have is 4, 3.2, 3.0, 2.7, and 2.2. For the delta of hydro, that is we have is 515, 381, 347, 305 here, and that is being dashed. So this is what we have is your atomic and physical properties of halogens here. Now we'll talk about for the another properties about it, which is that we have to discuss here, which is in the terms of F2. This is for Cl2, Br2, and I2. This is what we don't talk about it. And on the same cases for the same we have we'll talk about for the melting point, that is we have another property we'll talk about melting point. The another property melting point with respect to Kelvin, boiling point with respect to Kelvin, density gram centimeter cube inverse, distance x by x per pm, bond, dissociation enthalpy. Then we have here is E by P here as well, that we have to discuss here, that to be as follows, and that we will have to discuss here. Okay, so on the same behalf of it, and that is we have to talk about these properties here. In the same case for the melting point, that is for the F2 molecule we have here is your 54.4, 172.0, 265.8, 386.6. This is 84.9, 239.0, 332.5, 458.2, that is we have a dash as I told you. For the density it is your 143 and density is 1.5 which is 85. This is your 1.66 which is 203. 8.19 which is 273 and 266 here. That is your 4.94. Just write it down here only, 4.94, that is 293. Okay, so this is dash. For the distance we talk about it. Yes, for the distance is 143 and this is 199, 228 and 266 and then dash as well. For the bond dissociation enthalpy it is your 158.8, 242.6, 192.8, 151.1, this is dash. For the E by V we have 2.87, 1.36, 1.09, 0.54 and this has been the dash as well, that we have to talk about it. So here the radioactive for that Pauling scale for a liquid temperature, that Kelvin, that for the parenthesis solid half cell equation that we talk about it. On the same cases, if we go ahead with a further one that we have to talk about, that is another question here. The question is to be as follows, which is the halogens have maximum negativity electron gain enthalpy in the respective periods of the periodic table, and why, that we have to talk about it. So for the same we'll have to go ahead as well. The question is halogens have maximum negative electron gain enthalpy in the respective period that we have of the periodic table. Why? This has been asked, and the solution for this we can say that the halogens have the smallest size in their respective periods, and therefore the high effective nuclear charge. As a consequences, they are rarely accepted one electron to acquire the noble gas electronic configuration as well. And for the same cases, if we are talking about how the sulfuric acid being made here, and the flow diagram for the manufacture of sulfuric acid, that we'll talk about it. So yes, so I will just draw it for it, you all, that you will get to know about it, how we have to use it out that. So on the same behalf of it, we will be having a structure for this, and that is to be as follows. This is just represented here by the different pen, that is the flow diagram for the manufacture sulfuric acid. So that we have to discuss here, that is the structures we have as follows. On the behalf of it, that is we have a pipe here, so here we go ahead, and that's just your which is we have a dust precipitator as well. Then I will be labeling it out afterward, and that is that it was leveling it out. That we have. Then after that, so for the same case it will be coming outward, and that is inside for the another one. That we have. Was like this only. That it was connected to. In the same case, this is how the flow diagram for the manufacture of the sulfuric acid, that will label it out here as well. So in the same cases, this has been formed here. That has been represented here. It will go by one of the fuel that been passing it out. This is your dust precipitator. This is here, from here this has been the air. This collected one is your sulfur. This is here, that is moving here, it is your impure SO2 plus O2, and this is your sulfur burner. After that, for coming towards this one, this is your coming this is your waste water, that is coming it out, and here it is, this is water spray. This is wastewater, as I told you. After that, this is here, this has been inserted here, which is your concentrated H2SO4 spray. This is here, that is your waste acid. Then this is your coming towards here, that is, it is coming from here to here. This is your dry SO2 plus O2, and this has been here, this is your arsenic purifier containing gelatinous hydrated ferric oxide, and within this we have here this has been your preheater, and here it is your, that has been connected here. This is your V2O5. Here it is coming from here, that is, this is your SO2, and from here the same that we have. So this is being inserted. This is your concentrated H2SO4, which is to be as follows here. That we have, and that it is coming it out in the warp, that is your oleum, which is H2S2O7, and this inside in it, it's your quartz. Okay, so how it is working on, and that is representing here, which is that is saying the drying tower as well. This is from there, it is drying tower, and from there it is representing, it is your washing and cooling tower that has been represented here. So on the same, this is a flow diagram for the manufacture of sulfuric acid that we have to discuss it, even though we actually had discussed about it here in the detail about it. And now we will be going ahead with a different question, and then we'll coming towards that we have to discuss about the chemical properties as well. So the question we have come across is, although electron gain enthalpy of fluorine is less negative as compared to the chlorine, fluorine is a stronger oxidizing agent than chlorine. Why? That you have to talk about it. So let's go ahead with the question. That is the 15th question of the session that we have to discuss here as follows. In the same cases, we will be having go ahead. Although electron gain enthalpy of fluorine is less negative as compared to chlorine, fluorine is a stronger oxidizing agent than chlorine. Why? This we have to talk about it. So for the same, we have an answer for this. It is due to, just I write it down, it is due to, with the first we talk about a low enthalpy of dissociation of FF bond, and the second reason we have is high hydration enthalpy of fluorine here, that we have to, that even though we had discussed about it, and that is more in the detail about which we have to discuss about here. And on the same cases, there are some of the things that is very crucial that you have to go ahead and that you have to even do understood about it and gone through with that as well. So that is also important. But on the other hand, we can talk about it that there are many things to be discussed here. So with starting with the chemical properties, where we have to discuss about that is about the oxidation states and the trends in the chemical reactivity as well, even though which is also important one. But other than that, there are many things that, as I told you, we have to discuss on the same case, on the same phase. We can say that we'll discuss the different thing that is that we had done, and we can say that that's sort of a summary. We can go ahead on the same behalf of it, where if I'm going ahead, where the group 13 to group 18 of the periodic table, that consists of p block elements with their valence shell electronic configuration, which is we have ns2 and p1 say like 6 tak, and group 13 and 14 were dealt within the class that we have talked about, class 11th, and in this unit remaining groups of the p block have been discussed here. In the group 15, that consists of 5 elements, namely the nitrogen NPAS, SB and BI, that is very bismuth, and which have general electronic configuration of NS2, NP3, where nitrogen differs from the other element of this group due to the small size, formation of p-pi multiple bonds with itself with the highly electronegative atom like O or oxygen or carbon, and non-availability of the d orbital to expand its valence shells that we have to talk about it. And the elements of group 15 that shows the gradations in properties, and they react with the oxygen, hydrogen and halogens as well. They exhibit two important oxidation state, which is your plus 3 and plus 5, but plus 3 oxidation is favored by heavier elements due to the inert paired effect as well. On the same cases, the dinitrogen that can be prepared in the laboratory as well as in the industrial scale, it forms oxides in the various oxidation state as N2O, NO, N2O3, NO2 and N2O4 and N2O5 as well. These oxides have resonating structures and have multiple bonds in ammonia that can have prepared on large scale of Haber's process. And HNO3 is an important industrial chemicals. It is a strong monobasic acid and is powerful oxidizing agent. Where metals and non-metals react with HNO3 under the different conditions to give NO or NO2 as well. It talks about phosphorus exists that as a P4 in the elemental form. It exists in the several allotropic forms as well, and it forms the that hydrides that a pH3 that which is highly poisonous gas, and it forms two types of halide as the PX3 and PX5. PCl3 is prepared by a reactions of white phosphorus with the dry chlorine, and while PCl5 is prepared by the reaction of phosphorus with SO2Cl2, where phosphorus forms a number of oxo acid that is depending upon the number of POH group. Their basicity varies, and that the oxo acids which have pH bond that are good reducing agent as well. On the same cases, we'll go ahead further, which we'll have to talk about it, which is another one. We're in talking about the group 16 element that have a general electronic configuration, which is NS2NP4. They show maximum oxidation state, which is plus 6, graduation in the physical and the chemical properties in observed in the group 16 element in the laboratory. That dinitrogen is prepared by heating KClO3 is in the presence of MnO2. It forms the numbers of oxide with metals, and allotropic forms of oxygen is O3, which is highly oxidizing agent. Where sulfur forms the numbers of allotropes of these alpha and beta forms of sulfurs, and are most important. Sulfur combines with oxygen to give oxides such as SO2 and SO3. SO2 is prepared by the direct union of sulfur with oxygen, and SO2 is used in the manufacture of H2SO4. Sulfur forms of number of oxo acids amongst them, and the most important is H2SO4. It is prepared with the contact process, and it is a dehydrating and oxidizing agent. It is used in the manufacturing of several compounds as well. Now we'll talk about group 17 element that we have to discuss about here only, and that is another one. And onto the group 17 element that we even though had not completed yet. So yes, for after completing that, we will soon discuss about in the detail here for the group 17 as well as for the group 18 in detail that we had even though discuss about it. Now we will be going here to end up here, and that is also an important one. On the same behalf of it, we have to talk about it, and which is also an important one. On the same cases, before ending it up, as I told you here, that we had completed your sociology and your software engineering as well. Other than that, if I'm going ahead, where we had completed your reasoning here, which is being divided into two parts, which is your verbal reasoning and non-verbal reasoning. In the verbal reasoning, we had completed your general mental ability and the logic reasoning, and in terms of non-verbal reasoning, we had completed a series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, in completion of incomplete figure, and that we have to start with figure matrix, and after that we'll start with the discussion about paper folding as well. In the same cases, if talking about that is your quantitative aptitude. In terms of quantitative aptitude, if I'm going ahead, yes, we had that has been divided into two, which is arithmetical ability, where we had completed your operations on numbers, LCM and SCF of numbers, decimal fractions, and that is decimal fraction, and then after that simplification, square roots and cube roots, averages, and then we had started with another one, which is your problems on numbers as well. And hopefully in the next coming classes we'll end up with that as well. After that we talk about it, so that we had started with unit 1 in the chemistry, which is class 12. That is also important for the academic as well as for important for the competition as well. In that we had completed unit 1, which is the solid state, where we had completed the general characteristics of solid state, amorphous and crystalline solid, classification of crystalline solid, crystal lattice in unit cell, number of atoms in a unit cell, closed packed structures, packing efficiency, calculation involving unit cell dimensions, imperfections in solid, electrical properties, magnetic properties as well. After that, unit 2, which is the solution, we had started with, which is we have to completed the types of solution, expressing the concentration of solution, solubility, vapor pressures of liquid solution, ideal and non-ideal solution, colligative properties and determinations of molar masses and abnormal molar masses as well. After that we talk about it. So yes, for the unit 3, which is electrochemistry, we have to start with the electrochemical cells. We had done galvanic cells, Nernst equation, conductance of electrolyte solution, electrolyte cells and electrolysis, batteries of fuel cells and corrosion as well. In unit 4 we had done your chemical kinetics, which is the rate of the chemical reaction, factor influencing the rate of reaction, integrated rate equation, pseudo first order reaction, temperature dependence of the rate of the reactions, and of course the collision theory of the chemical reaction as well. After talking about it, we had completed unit 5 as well, which is the surface chemistry, where we had completed adsorption, catalyst, colloids, classification of colloids, emulsion, right around us. Unit 6, we had completed general principles and processes of isolation of element, which is the occurrence of metals, concentrations of ores, extractions of crude metals from the concentrated ore, thermodynamic principles of metallurgy, electrochemical principles of metallurgy, oxidation, reduction, refining, uses of aluminium, copper, zinc and iron. In unit 7, we had discussed about the p block element, which is group 15 element, dinitrogen, ammonium oxides of nitrogen, nitric acid, phosphorus, allotropic forms, phosphine, phosphorus halides, oxo acids of phosphorus. For group 16 element we had completed, that is dioxygen, simple oxides, ozone, sulfur, allotropic form, sulfur dioxide, oxo acids of sulfur as well. And other than that, if I'm talking about here, that we had talked about it, which is about the sulfuric acid as well. And group 17 elements, we have to start with it, and that we have started with, we have to start with the chlorine, and then we have to discuss about hydrogen fluoride, oxo acids of halogens, entire halogens compound, and group 18 element that we have to discuss in the further next coming class. After completing that, we'll start with the discussing about unit that is your 8 here. In that we have to discuss the D and F block element, where we have to discuss position in the periodic table, electronic configuration of D block element, general properties of transition element, HSD blocks, some important compounds of a transition element, the lanthanides, actinides, some application of D and F block element as well. Unit 9, we have to cover up the coordination compound, which is the oneness theory of the coordination compound, definitions of some important terms pertaining to the coordination compound, nomenclature of coordination compound, isomerism in the coordination compound, bonding in coordination compound, and then after that we have to cover up here, which is your bonding in metal carbonalysis, stability in the coordination compound that we have to discuss here. And after that we have to cover up the importance and application of coordination compound as well. So here we will be ending it up, and first of all, before start ending it up, it's a huge request from my side to all the viewers to please go through with the subscribe button, please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And thanks to all those subscribers, those who had supported us from starting until now, thanks to all of you, and thanks for appreciation and thanks for suggestion as well. So stay tuned with us, and thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.